Okay, so in section 3 point... Why isn't this working? Oh, just a hiccup. Okay, in section 3.2, Rolle's theorem and the mean value theorem, we're doing problem number 67. And problem number 67 is more of a thinky question than it is a doey question. The question says, two bicyclists begin a race at 8 a.m. They both finish the race 2 hours and 15 minutes later. So, they finish in a dead heat, right? Both tie. Prove at some time during the race the bicyclist traveling at the same velocity, right? Okay. So we have, let this be a graph of our two bicyclists, where the horizontal axis represents time of the day, and let's let this be 8 a.m., and this will be 2 hours and 15 minutes later, or 10:15 a.m., right? Some time later. Okay. Okay, so let this be distance along the road, where this value right here is the start line, and if this is a windy road, let's just consider the mile markers to be the value along this vertical axis until you get to a point where this is the end, or the finish line, right? Finish line. Okay, so we will plot in blue our one bicyclist starts, right? And let's say that he's very conservative and starts off really, really slow, right? And then right at the end decides that he is going to pick up his speed and finish, right? Okay. Let's let the red racer start off really fast. And he pumps and really gets really fast, right? And then he starts to lose some of his wind, and he starts to slow down a little bit. But he continues on until he reaches the end point. The two strategies are, well, obviously the results speak for themselves. They're just okay because both guys finished at the same time, right? All right. So these two functions are two continuous functions. And they're also probably going to be, we will consider them differentiable functions, right? They're smooth. The racers don't stop suddenly in the middle of the race. They're always kind of picking up their paces and losing their paces in a nice, smooth fashion, right? So we will just consider in this interval between here and here that the function is both continuous, both functions are continuous, and they are differentiable. And showable. Okay. So, what is the average speed for both of these racers? Well, all you have to do is find when they started, find when they finished, and subtract the end distance from the start distance and divide that by the amount of time, right? Essentially, that is just the secant line, the slope of the secant line that is created between these 2 points. If I could only draw a nice straight line, which I can't. But imagine that this line is nice and straight. So, by the mean value theorem, if you have an interval which is continuous and differentiable, a function which is continuous and differentiable on an interval, the instantaneous velocity, or the derivative of the function, has to be equal at some point from between when you start and when you finish to the secant line, or to the average velocity, right? So there must be some time in between where you start and where you finish that your instantaneous rate of change has to be the same as your average rate of change. For the guy with strategy A, our blue racer, he starts to pick up his speed at some point later on, right? For our red racer, he starts to lose some of his speed earlier on. But their instantaneous rate of change will be equal to their average rate of change, and since their average rate of change is equal, this line is parallel to this line is parallel to this line, so therefore this line has to be parallel to this line, giving you the idea that at some point their speeds, or their rates of change, had to be equal. So that's the answer to the question. Prove that at some time during the race, the bicyclists are traveling at the same velocity, at the same speed. And that is the proof by the assumptions that we make here and by the mean value theorem. Okay, and that is the answer to that question.